Hi, I'm Jesse Treger with the Big Data Analytics team in the Intel Data Center Software Division. I am responsible for marketing and business development for the Intel Data Platform Analytics Toolkit. I'm here at the GigaOM Structure Conference giving a preview of some technology that we call the Analytics Toolkit for the Intel Data Platform. The toolkit is designed to help data scientists uncover hidden insights in their data more quickly and more easily using powerful capabilities of graph analytics and machine learning. So contrary to what many people think when they hear the name graph analytics, in this context, graph has little to do with the kind of charts you build for PowerPoint or Excel. In this case, graph refers to the type of data that you can think of as a network. Anytime you have two objects that are connected by a relationship, something that you could visualize a network, you're basically working with graph data. And graph analytics is the way of finding insights about that data by working with the relationships between the data. You can use graph databases to search and query data with its relationships. You can use graph analytics engines like Apache Giraffe to do machine learning and make predictions about the relationships between entities. For example, what Google does to do PageRank is an example of a graphical machine learning. And you can use graph visualization to visualize data as a network. When you have highly connected data, such as you have with big data, graph tools is usually easier, faster, more powerful for finding insights about the relationships between the data. So we're bringing to market within our toolkit the capability to work with graph data alongside of classical machine learning across the data science workflow. So the data scientists have access to all of the capabilities, they're not limiting their creativity, and they're able to really find the hidden insight that may exist in the relationships between the data in ways that you just can't access with classical machine learning alone. There's a couple of innovations that I'd really like to highlight in our analytics toolkit. First of all, we're delivering one of the first end-to-end graph pipelines running inside of the Hadoop environment. By end-to-end pipeline, in this case, I'm talking about the ability to structure the information into the network of nodes and vertices using scalable graph construction capabilities. We have a fully scalable graph database for OLTP use with graph data. And we have algorithms and fully scalable infrastructure using Apache Giraffe that works alongside the graph database to help you easily access graphical machine learning capabilities. In addition, we have classical machine learning using Apache Spark. And all of these run inside the Hadoop environment based on open source components that we've modified to make the data flow seamlessly through these different components. Perhaps most importantly, rather than expect the data scientists to tackle the complexity of learning all the low-level APIs and programming in Java and programming in Scala through all these different Apache projects, we've layered on top of the toolkit a very friendly, familiar programming environment for the data scientists to use. So they can program in Python and under the covers run at cluster scale. So for a data scientist who's familiar with running Python on their desktop analytics, the experience will be totally familiar, but under the covers they have the full advantage of the Apache Hadoop ecosystem to run their analytics and machine learning at scale. Perhaps it would be good to give you a quick glimpse of the environment that the data scientists would see to program at cluster scale using the easier Python environment that we've built in the analytics toolkit. Okay. This is an example of the environment that the data scientists can work in to make it simpler and easier to develop advanced analytics and machine learning. Instead of writing at the lower level Java and lower level programming, they can work in the familiar Python environment that you see here. You're seeing a user environment that's running in IPython, and you'll see commands and APIs that we've written that abstract away the complexity from the underlying Hadoop infrastructure. Here you can see commands being used to load data into the toolkit. This is a set of sample data that is illustrating how you might build a recommender system, such as you might experience from one of the major service providers. Here we're parsing the data. Here we're parsing the data. You can then clean the data. Again, working across the data science workflow and letting the data scientist iterate within a single environment without having to go write a lot of glue code, move back and forth between tools and environments. All the data flows seamlessly between the various parts of the workflow. Here you can see how easy it is to build a graph at scale with our Intel Graph Builder software. Under the covers, made simpler here with the Python environment. This will go connect all the vertices and edges to build a large-scale graph and load it into the graph database. And here in the next step of the demo, you can see how easy it is to call a graphical machine learning using Apache Giraffe and the algorithms that we've provided, in this case a conjugate gradient descent algorithm that you might use for building a recommender system. You can see how easy it is to call it using a very simple Python call, as well as the visual cues that you'll get to help you work with the data and understand how your model is converging. So there's a lot of capabilities in the Intel Data Platform Analytics Toolkit. But in particular, if you're interested in trying to explore how graph analytics can help you find the hidden relationships in your big data, you can learn more at www.intel.com/graph.